My name is Mark Bridger from Alteryx, and I'm here to welcome you all to this packed auditorium for the McLaren presentation. Back in March of this year, Alteryx and McLaren started a partnership that is already proving a win-win for both of us. Not only are we involved in the design, the build, and the run, but we're also involved in enhancing the F1 fan experience. So it's my pleasure to welcome Ed Green to the stage, Head of Commercial Technology for McLaren. Before I do, it would be remiss of me not to say congratulations for the P1 and P2 back in Monza. And with that, I'll hand over to Ed. Thank you.
Cool. Well, thank you very much. And yeah, pleasure to be back, and pleasure to be back in person joining you and explaining a little bit about our relationship with Alteryx. A P1, P2, fastest pit stop, fastest lap, and second in the sprint qualifying. Yeah, it was not a bad weekend last weekend. I was a little bit worried my voice might be a bit croaky still. There was a lot of celebrations in the office, a lot of champagne being drunk on Monday morning. But anyway, a little bit about who we are at McLaren. So many people know us as the Formula One guys, right? We go racing around the world 23 times a year, 23 different countries, usually. A little bit of a COVID blip this year. But we normally known as F1 team, right? We've been doing this for over 50 years, racing right at the edge, and being sort of pioneers and trailblazers in what we do. We're one of the first teams ever to use a carbon composite chassis, which is now used by every single F1 team down the grid. We were the first team to place sensors on our car. So about 30 years ago, we placed 24 sensors on our car, and I'll show you how many we take out with us and tomorrow afternoon when we're racing out in Russia. But it's not just been 50 years of Formula One. We've also been competing in IndyCar. So we raced over in the US in the oval circuits out at the Indy 500 and had good success winning 3 championships over there at the Indy 500. And more recently, we've now taken a majority stake in an IndyCar team. So alongside the Formula One racing side, we also have a majority stake in McLaren Aero SP. And we're starting to take the learnings and developments we have in Formula One over to the team in IndyCar. So how do we simulate? How do we look at aerodynamics, config setups? And we start to have good success, and we're currently running second in the championship with Pato O'Ward over in Indianapolis. And then outside of the sort of physical racing of Formula One and IndyCar, we've also moved into esports. And we're one of the first ever Formula One teams to launch an esports program called McLaren Shadow. Why Shadow? All of the drivers follow the same training regime, the same development goals, they follow the same training maps as the real F1 drivers. And we've been able to take people that have gamed in their bedrooms and put them through this development program, shadowing Lando, shadowing Daniel, and all of our previous Formula One drivers, and they've then entered into our simulator. So they've been able to take those skills from gaming and then move into a really high-fidelity simulator that we have down at the MTC. And then finally, kind of exciting for this year, we've also announced a new sport for us, one to challenge us, which is Extreme E, which is the 4x4 electrification series. And that's really, driving our thoughts about sustainability and how do we as a Formula One team put our efforts, our know-how, all the knowledge we've developed over the last 50 years into the electrification space and launch our Extreme E team, which we're hopefully doing pretty soon, and we'll be heading into the series next year, which is an exciting challenge. And my role at McLaren is to look after all of those racing series and look after technical stacks that go into them alongside our partners. But it's not just Formula One. We've also got an applied business, and this is where we've taken the world of battery-powered ECUs, and we've developed these systems now used by lots of different motorsport series. So NASCAR, Formula E, if ever you've watched that as well, and we provided those services into other teams. So in fact, the sort of joke inside the business is that any weekend a car crosses the line, first or second, there's always a bit of a McLaren inside it from our ECUs that do that for us. And I'll go into a little bit more about what the ECUs do for us. And then finally, the kind of sexiest part of McLaren, and sadly I don't get to drive onto the office every day of the week, is the McLaren Automotive business. And this is where they produce stunning supercars, sports cars, hypercars, and really, when you look at that business, that's only 10 years old, which is strange to think about when you look at some of the cars like the 720, the new Alteryx, which is a fully electric hybrid car, and then a car like the McLaren P1. So the McLaren P1 was released in 2 years from start to finish. And that's kind of unheard of in the automotive industry. But the reason they're able to do that is learning from Formula One teams about how do we simulate part development, how do we simulate the release cycle of new technologies. And so to go from concept to release in 2 years was pretty extraordinary. And it's a part of the business we work closely with, and it's pretty exciting. So what do we do in McLaren each race weekend? So when the cars go out on track tomorrow for free practice out in Russia, they will be taking on board about 600 sensors each. Those sensors measure over 100,000 parameters on the car, and we get that connectivity as the cars go round the track over 200 miles an hour back to our garage at 2 megabits per second. The sensors on the car will measure all sorts of parameters from suspension ride height to wheel velocity to gearbox changes, which are measured incredibly quickly. And some of those sensors measure us once a lap, how quickly are we going, what was our lap time. And other sensors come off at 100 kilohertz a second. So every second we've got 100,000 data points coming back into the factory. That's critical for reliability. You can imagine what the team were like last weekend, trying to make sure both cars were going to cross the line. But there's a huge amount of data coming from the cars each race weekend. And in total, every weekend we go racing from the Friday through to the Sunday afternoon. There's about 1.5 terabytes of data generated by both cars back to the factory. And whilst we have a team that goes out to the track, we don't analyze and do all of that computing and all of that telemetry crunching at the track. We need more people to kind of add context, to add their decision-making skills. And so whilst those cars are going around, in the garage, we have our edge compute. We send 2 engineers to every single Grand Prix as part of the IT team, and they look after this 2 tons worth of IT that we send around. That's got telemetry servers, it's got strategy servers, simulation, weather servers, and quite frankly, if that IT rig doesn't start, and we can't see both cars and prove to the FIA that all of our systems are running, we're not allowed to release the cars on track. And so it can be pretty stressful, pretty fine timings, and our SLAs are measured in minutes, not hours or days or weeks. And so a P1 for us is anything above 3 minutes. That means the cars can't go out on track. In the garage, you see the pit lane where you've got Andreas, our team principal, Andrea, our race director, our head of strategy. Zach sometimes sits up there as well to give his insights and his ideas of what we should be doing. But we've got a huge amount of people sat on the pit wall. We've then got the engineer battle stations, so an engineer for each driver, a reliability performance engineer for each driver, and then we've got head of tyre wear, head of strategy as well. But if you just had those people in the garage, we probably wouldn't be very successful going out racing. So all of that data comes back to Woking, just down the road, into what we call mission control. And if you've watched Apollo 13, that big kind of, big data wall with all the engineers sat there, we've got our very own version of that with 32 engineers sat inside this room with full comms, full connectivity to the track, and the latency is somewhere in the region of 200 milliseconds, give or take, where we are in the world. Silverstone this year was 57 milliseconds. So we also have to program our systems to make sure in 57 milliseconds an F1 car goes quite far. So we program and put the latency into a lot of our software tools to make sure we're making a decision where the car is actually on the track at that given time. So back at the MTC, because we're not flying people around the world, those 32 engineers aren't the same people all race weekend. On Friday and Saturday, we tend to have a lot of strategists, aerodynamicists, reliability engineers, and they'll be sat in there with comms to the track, helping make decisions for the race team. And in fact, all of the decisions to pit the car come from Woking. So we're looking at the data. There's 2 strategists, Ollie and Will, and then led by Darren, and they sit at the back, and they will look at all of the data, and they will help Randy on the pit will make the right call at the right time when to bring those cars into the pits. Now, why is that important? Your decision to bring the cars into the pits, tell the drivers, tell the pit crew, and make that decision about are you going to come into the pits, what tyres are going to be put on, can be as little as 3 seconds. So in that 3-second window, you've got to see safety cars come out, where are we on track, and if you get it wrong, race over, you're at the back of the pack, and unless you're a Finn with a Mercedes car, you're not going to do very well at overtaking everybody. So you've got to make that decision pretty quickly. And so constantly throughout the race, we're running simulations. And it will start on a sort of Tuesday afternoon. We'll run 300 million simulations of the race. So every single race weekend, 300 million simulations of what might happen. So to do that, we burst into the cloud. We take advantage of public and hybrid clouds. We've also got private bare metal that we run as well. But all of that simulation data takes place up in the cloud for us. On a Tuesday afternoon, we spin up 4,500 VMs in various different cloud providers just to crunch and run all those different numbers. And then you get onto the world of sort of the strategy and modeling, and during the race, because that's so low latency, we run all of that on-premise at the McLaren Technology Centre. And then throughout the course of the weekend, when you move into Sunday on the race, you don't need to decide aerodynamics because you can't change it. So at that point, we invite volunteers, graduates, anyone across the company can volunteer and say they'll come in. I've done it before. It's good fun. You put on a headset and you listen to the team radio of every single driver. So you might have Lewis in one ear or Kimi in another, and you'll transcribe and make notes as to what those different teams are doing. That's important. If you hear a word like box, 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 that's the phonetics, that's clear on the radio, that means they're going to come into the pit stop. And then you start playing the game of the undercut or the overcut. But these are areas where we're looking to sort of deploy new technology so we can use voice recognition to pick up those moments when the drivers are saying box, 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 is that the right time to go into the pits? It's also good fun to play games with each other. So often our drivers, they're not the best actors, but they'll come on the radio and start moaning about tyre wear and see if we can draw other teams out, in which we've done a couple of times this season, which is quite good fun. But you're listening to other teams to see if they're trying to do the same thing to us, what those might be, and listen for those code words. So what do we take to track? We take just shy of 70 logical cores. Storage has gone up a little bit this season, so that's now 140 terabytes. The memory, we just deployed a whole new trackside cluster, so we now take 4.5 terabytes of memory to each race. And on average, each weekend, we read and write over 12 terabytes of data just at the track alone. So that gives you an idea of the sort of scale of compute we have to take with us. And as I say, if we don't get that right, we don't go racing. This is mission control, so it gives you an idea of what that environment looks like. This is last season. We don't tend to take photos midway through the year. And so you see Lando's side of mission control and Daniel's side of mission control. And there's some shared resources, so a couple of our engineers will sit in the middle and they're shared resource, but not too much. So why do we have all this, and how does Alteryx start to play into this for us? Well, it's all about decision points at the greatest point of knowledge. Anybody in the team can make the decision to stop the car if they think it's unsafe on track. But all of these experts start to feed in their individual and their sort of human representative thoughts, opinions, experiences into what we call our kind of decision-making support tool. The drivers get really angry if there's about 30 people talking at them at any one time, so we tend to only have one person that's allowed to talk to the driver. And so you'll see there Tom Stallard, who's actually a former Olympian, but he talks to Daniel, so you'll hear his voice if ever you watch on Sky. He gets a bit of notoriety for calling Daniel Carlos every now and then, which is embarrassing. But the race engineer and the driver have a really clear way of comms. And so everyone's listening to what the drivers are saying, but that goes into the race engineer. That then comes back into strategy, that comes into our driver strategies, and then all these decision-making support tools. So why is that important, and how does Alteryx start to play into that for us? Well, we're looking at lots of live data, but we're also looking at lots of historic data that we need to merge and start to bring together. So if we go racing at new tracks, so for example, Zandvoort was a completely new track for us, what we'll start to is we'll allow engineers and data scientists to profile corners and look for similar characteristics. Now we'll be doing that in aerodynamic models as well, and we're doing that across previous drivers and as well as the simulated data. So all of those different data points coming from the simulator, our CFD cluster, maybe racetracks, we've profiled that a corner looks very similar to a corner in Zandvoort. We'll start to use Alteryx to bring a lot of those data points together and feed people the right information, which they then feed into this decision-making support tool on a race weekend. And maybe that's around reliability of gearbox, maybe that's around the tyre wear, tyre degradation, but people will be sat there building their own models. I think one of the impressive things for us, sort of starting this journey with Alteryx, is as an IT function, the team that I sit in, there's only about 12 of us that run IT for the F1 team. That's not to say that the rest of the team isn't IT literate and don't produce their own platforms, they do their own coding, but there's 12 of us that run IT for McLaren. And so with that, you've got to pick platforms and pick technology that your team can use and embrace. One of the things that was quite cool with Alteryx was how quickly they got people up and running. So rather than sat there doing workshops, and I'm sure everyone hates sitting through workshops with a whiteboard and post-it notes and coming out of it with a picture that you have on your iPhone in amongst your family pictures, we started doing workshops with Alteryx with our own data. So people arrived with aerodynamic models, we arrived with fan data from previous campaigns we'd done, and actually that was really interesting because we got hands-on with it really quickly. And that then inspired people to go around the team saying, whether or not it was in digital manufacturing or in the social media team, I've just used Alteryx to produce this, and how quickly people get it deployed. Our biggest critics are our data science team because they think they're the creme de la creme and they know what they're doing, but they loved it and they wanted to push it out more, and they've built modules and packages which we're pushing into the team. So in a sport, we're quite lucky that every weekend we go racing is a new prototype of the car. I think you'd be pretty concerned if you jumped on your transatlantic flight and they told you they're just trying a new part of the plane that weekend. But in our sport, we're pretty lucky that we get to do that. Every weekend we go racing, we can try new bits of the car. But with that comes even more data and even more challenges on how do you decide what to put on the car and when. And in truth, it's quite complex to understand what's on the car throughout the course of the weekend. So to decide what goes on the car, you first have got to design it and come up with an idea. So we start that in computer-aided design in CAD world, and our engineers and designers will start designing a new part that they think might give us what we call downforce points. And generally, once you're into the season, you're not looking for huge changes, you're looking for downforce improvements or areas we think we can be quicker. So once you've designed your part in CAD, that means you don't then put it downstairs into the workshop and produce it straight away. That's a very expensive way of experimenting. And because you can only run these cars on track for 3 hours in practice mode, then a qualifying and then race, it means we don't get the luxury of running the car all the time to experiment and collect more data. So we have a fully digital twin of the car, which exists inside computer fluid dynamics, inside almost like a virtual wind tunnel, where we analyze every square centimeter of air that flows over the car. And so we simulate these CAD models, put them into the CFD cluster, and run them through. The brain of the CFD holds about 6 petabytes of data on the car, and when you do a full run, you can generate over 25 petabytes of data just on the aero models of the cars alone. We don't keep all of that, we discard quite a lot of it quite quickly, but you get a huge amount of data coming out from those models. Our CFD cluster is heavily regulated. We can't just go and throw more memory at it. We can't throw more processors. It's regulated, it's inspected. Every single serial number goes to the FIA. So our time running in this virtual world is also quite limited. But if we have good success in the virtual world, which often happens, you'll then bring that into our 3D printing, and we'll 3D print a part at 60% scale and then put that inside our wind tunnel. Again, wind tunnel time is also quite restricted, so you're trying to get the data as quickly as possible out the wind tunnel. You're doing this between races, and your production times are pretty low as well. Then how quickly can we get it out of the simulated world, 3D printed, into the physical wind tunnel, we capture more parameters from the car, and then how quickly from that can you make a decision as to should you put this on the car. So we've started using Alteryx in the back end, so taking all the data coming from the simulated world. We've now started taking all the data coming from the wind tunnel. We're just designing a new wind tunnel at the moment, so that's quite exciting for us. And then the game is once you produce that part and send it to track, and I said those 300 sensors, collecting all of those different parameters, is how do you know if that part's been successful? How do you know whether or not that's a good thing for us to be then putting on the car or not? The quicker you can correlate that data, the quicker you can put parts fully into production, or the quicker you can make a decision as a strategy team to then run that part on the Sunday. And typically, development parts go through the first test. They typically don't make it onto the car for Saturday, and then we'll wait a week before we put them back on the car for Saturday qualifying. So that's quite a short decision window you've got to make between everything else going on the race weekend. What do you do? How do you get it onto the car? There's change freeze on a Thursday night, so you get sort of inspected by the FIA. But there's lots of different sort of parameters there to make sense of. And Alteryx was kind of an obvious choice for us to start to bring all of that together just in the aerodynamics world. That's vastly complex and a huge area of R&D. Now, going into next season, into 2022, for those of you that follow the sport, is going to be a huge aerodynamic rule change for us. Lots and lots of different aerodynamic changes to the car. The rear wings get bigger. The shape of the car changes. You've got bits that cover the wheels now. And so going forward, aerodynamics is a pretty important part for us. But typically in any given season, we produce somewhere in the region of 16,000 parts that change on the car. And from in a typical season, I say typical season because last year was a little bit different for us. Generally, you only carry over 10% of the car, and you will reproduce somewhere in the region of 60,000 parts over the course of a season. So in 6 weeks, 16,000 parts become obsolete. That shows you the rate of development and rate of change that has to exist, and why we're sort of always launching this constant prototype to go racing with. There's a huge amount of data that comes from the design of the parts, whether or not that's the machines themselves, whether or not that's the procurement systems, the quality checks. We use a lot of lasers and modeling and scanners, ultrasound machines to check the quality of parts. And when the car reaches the track, you can have over 17 different data sources just on how did a part get to the car. So when we unload the car in Russia yesterday afternoon, it's not always clear how those parts have been developed, how do you bring those data sources together. And as we enter into the next season with the kind of increased pressure on the Formula One cost cap, so that means $145 million to run your car, $30 million every 3 years to invest in the team, and that we come down by $5 million a year for the next 2 years, I think. Actually understanding the cost of your car build is critical. So we've got 17 different places we can go and look, from finance to procurement to project management. But to get all that data together means we don't know the true cost of running our car normally until about 10 days, 2 weeks until we've been racing. So that was a key area that we sort of nominated Alteryx to get involved with. They've started taking those data sources, bringing them together, munging them together, and we started to model out what we think that might look like. That's quite hard in a Formula One season when you think, Lando had a bit of a shunt out in Belgium. That means a brand new floor, but with something like Alteryx now, we can start to model and predict, well, how much time goes into machine shop, what additional hours are needed, is that overtime that's needed, can we look at upcoming workflows to say, what do we do? And all of this whilst you're balancing the development of this season's car and the development of next season's car. So actually, we stopped developing the 2021 car this year probably after the 4th race of the season, and most other F1 teams did the same because there's so much to do. So when you do have a problem with a part, or you've got to go and reproduce something, that means you've got to go backwards. That means you've got to stop production of next season's car and move on to something else. So Alteryx bringing that all together for us, it means that it's not down to my team, it's not down to data scientists. It means people on the floor, it means people in the machine shop can start to use this tool and start to get out there and make some decisions about what they produce on any given week. But ultimately, it's all about going racing, and when you do, the sort of common line we give is the car that starts the season and finishes first. So the Red Bull or Mercedes that crossed the line in the first race of the season, which is normally down in Australia, if you did the full race calendar and didn't touch that car and did nothing to it, it would be stone dead last by a matter of seconds by the time you finish the season, typically out in Abu Dhabi. So that's the course of sort of 9 months worth of development. If you did nothing to it, your car would be dead last and you'd be at the back of the grid. So you constantly have to be out there innovating, trying to find new ways. And our performance differentials can be as little as 0.1% or 0.15%, down the back straight, or when you watch some of the qualifying to see how fine the teams have a margin between them where they end up on the grid. And in some cases that might be a bit more generous, we end up with 4% difference. But hopefully that gives you some sense of the scale we work with data, how quickly we're having to iterate, the marginal gains we try to find, and why pursuing a small part in the car to shave off 0.5 gram might be totally worth it, or simulating and developing new sensors virtually for the car to shave weight on a Sunday afternoon are more important for us as we go forward. I'm going to wrap things up there because I think we're sort of nearing-ish end of time. I'm happy to take some questions now, or if not, then you're welcome to come and grab me for a little while. I'll be joining the team at Alteryx on their booth afterwards. But if anyone's got any questions, happy to take them or come up for a chat afterwards. But thank you very much. Yeah, I think we've got one question if a microphone can be.
Thanks very much. Excellent. You, right at the end, you said how critical weight was down to the nearest gram, and I think you started by saying you had about 260 sensors. There must be a cost-benefit ratio with respect to weight and the information that's come. How do you actually manage that as well?
Yeah, so weirdly, you can't always tell how fast the car's going. You can measure the revolution on the tyre, but that doesn't always give you the speed of the car. So you have something called a V sensor, which is a laser that scans on the bottom of the car, and that gives you really accurate speed of how fast you're going. But that sensor weighs about 450 grams. So do you want to know how fast you're going, or do you want to save some weight? Which is a really weird, that's like a really obvious and really weird question to ask. So in those areas, we start to look at developing virtual sensors, or can we use AI technology to predict if we know what the rest of the car is doing, we might get a better idea of how fast it's actually traveling. And then in truth as well, on a race weekend, we will run 300 sensors on the Friday, Saturday morning, and then by the time we get to qualifying, and by the time we get to racing, we'll trim off anywhere between 80 and 100 sensors from the car as well. So the guys will take off the front wing and they'll start removing different sensors that come from the car. The ECU on board, it can only send us information at 2 megabits a second. We're connected back to the UK at 70 megabits a second, so it's not like we've got all the bandwidth we'd really want. So that ECU also has to make intelligent decisions. We can't tell the car what to do. That would be not very sporting and make Lando and Daniel's life a lot easier. But the car can tell us what's going on. So we can also ask the ECU, stop sending us gearbox data, but we really need to see what's happening on the front left suspension because we've got an issue. And so you can tweak the V sensors, and you can tweak the ECU slightly throughout the race to get sensors at different speeds as well. Anyone else?
Hi. First of all, thank you. It's a really exciting talk. And I have a bit more of a technical question. So you were talking about CFD calculations, and well, CFD calculations are incredibly expensive, clearly. And one of the things that I'm curious is, so if you take CFD and, let's say, physics-based modeling, first principle modeling on one hand side, and then you look at data-driven modelings at the other hand side, do you have an estimate on how much you rely on each of them, like a ratio or?
So I think because it's regulated, it's hard to give an estimation. So you take as much as you can from the CFD world. You can tweak it slightly. So you can do, so for example, reliability modeling that falls outside of the world of CFD. So we kind of tend to do more simulations on crash structures and part reliability. But I think it's a difficult one to give an answer to without giving away too much of how we weight ourselves against other teams, because everyone can play their credits slightly differently. But I think it's an interesting area that we'd like to model more because it may give us an advantage in some of the regulations, but that's probably as much as I can say. But thank you.
Hi. So McLaren's performance has improved quite significantly in the last several years. How much do you credit your data strategy for that improvement, and how much would you say is other factors?
I think our drivers would probably have something to say about that, and they'd probably say that they're doing a pretty good job. I think you can't make those incremental gains, and you can't push forward in the sport unless you have got a really robust data strategy behind it. And so those incremental gains where you're moving the needle ever so slightly, I think data is critical for that. And I think there's two ways to look at it. One is how do you inform your designs and your decision making, and the other one is how do you activate it and use it in a race on a Sunday. And so I think on the race on the Sunday, I think we do a really, really good job with data. I think we probably do a better job than most other teams. We come back to the factory, and on a Monday morning we replay other teams' strategies. And so we play along as if we were Ferrari or Red Bull, and we'd say, what would we have done at that point, and how would that have affected their race? So I think that the in-the-moment stuff, I think we do a really, really good job of it. I think the data strategy is pretty critical, more so when you're making change. So we did a big power unit swap out from Renault to Mercedes HPP this year. You can't do those type of activities unless you've got a really good data strategy, a really good data stream to start to inform how that make the car better. Will that shred our gearbox? How is it going to impact the aeroflow around the back of the car? So I think on those design areas, we've been very fortunate, and we've continued to capture more data than we possibly need. On the Sunday, I think we do a really good job. There's a lot of pressure coming on the team to do more with it and make better strategy calls. So yeah, hopefully that gives you a sense of how we use it in two different areas. But yeah, cool. Thank you very much.